Today we'll be learning about the volume of a cylinder. We'll be going over the TEKS 8.6a, and the student will learn about the volume formula for a cylinder and describe the parts of the cylinder volume formula. We'll begin by recalling some familiar terms, and please make sure that you make a note of these terms because they're really important. Volume is the amount of space an object takes up, and a cylinder is a 3D figure with two circular bases. So let's find the cylinders in this image. So we've got toilet paper, that's a cylinder. We've got tomato soup, that can is a cylinder. The soda can is also a cylinder. And this drum. So a really important component of this lesson is remembering order of operations. Most of us learned this back in 6th grade. Remember, this is PEMDAS. First is parentheses, then exponents, then multiplication or division, and lastly, addition or subtraction. So we also need to remember the difference between radius and diameter. Radius is half of the diameter, and the formula for the area of a circle is pi r squared. In today's lesson, I'll introduce to you the formula of a cylinder, and that is pi times radius squared times height. At times, you may see the formula of a cylinder written as big B times height. And big B stands for the area of the base. And because the base of a cylinder is a circle, this big B stands for the area of a circle. So we're just replacing the big B with pi r squared. And once the area of the base is determined, then we can just multiply it by the height, and this will give us the volume of our cylinder. All right, so let's jump right into some examples. So here we have a cylinder that has a radius of 8 centimeters and a height of 15 centimeters. We're going to find the volume of the cylinder. Our first step is to write down the formula. So that is pi times the radius squared times the height. Our next step is to plug in the given values. So let's bring that down here. We have pi times the radius squared, which is 8 squared, times the height, which is 15. Step 3 is to solve for the exponent first, because that is first in the order of operations. So now we have pi, we can just bring that down, times 8 squared, which is 64, times 15, which is our height. Step 4 is to multiply the remaining numbers. So we can do it in parts or all at the same time. Our volume should be 3014.4. And the final step is to write your answer with cubic units. So our units here would be centimeters cubed. And our final answer is 3014.4 centimeters cubed. So I do want to go over some common mistakes with you guys. So be cautious not to miscalculate the radius. Remember, the radius is half of the diameter. Also, make sure that you follow the correct order of operations. So remember PEMDAS. And remember to always attach the correct cubic units to their volume results. So this could be cubic inches, cubic centimeters, cubic feet. Example number 2 states, Kai and his friends saw a giant cylindrical aquarium filled with fish. If the radius of the aquarium is 6 meters and its height is 18 meters, how much water can the aquarium hold? Now here we can see a picture of the cylindrical aquarium. So first, what do we know? So we know we have a cylinder, we know the radius, and we know the height. What do we need to find out? What is this asking of us? How much water can the aquarium hold? So it's asking for volume. So we're going to use the volume of a cylinder formula, which is pi times the radius squared times the height. Now we're going to solve this step by step. So first we're going to substitute in the radius, which is 6, and the height, which is 18. And then first we're going to solve for the exponent here. And now we have pi times 36 times 18. And then we can just multiply this straight across, and we should get 2034.7 as the answer. But is that our final answer? Nope, because we were missing the units. Our final answer is going to be 2034.7 meters cubed. Now for examples 3 and 4, I want you to watch this short YouTube video and pause the video at 110 and work out the problem on your own, and then check if you got the right answer, and then do the same thing again at 224. So you might be asking yourself, why does any of this matter, and how do we use the volume of a cylinder in real life? Well, volume helps us determine how much material can be put inside of a container, like how many chips will fit in the Pringles can, how much soup will fit in the Campbell's can. We have cylinders all around us. Did you know that the most common figure used in real life is the right circular cylinder? We use it for things like water bottles, deodorant cans, soda cans, and understanding volume really opens the doors to higher level math and careers in the STEM field. Okay, now let's review really quickly the steps to calculating volume of a cylinder. The first step is to write down the formula. The second step is to substitute in your given values, so your R and your H. The third step is to work out the calculation, but don't forget about the order of operations. The fourth step is to write the final answer with the units, and don't forget the units are cubed when we're finding volume. Next class, we'll do some hands-on exploration, and we're going to find and compare the volume of 2 cylinders in order to determine which figure will hold the most popcorn. And yes, I'll give you some popcorn to snack on. So remember to bring your notes that you took during this video to class tomorrow, and also bring the work that you completed in order to do the matching game.